Hello and welcome to T2 Day 11 of Honors Precalculus. We're going to continue with our journey through trig. So if we attempt to find all of the solutions of this equation on this interval, it's nice, kind of clear for you now, on this interval, what do? Well, the key thing here is you might try to factor it, you might try to do some stuff, but the real key thing, just jumping to the conclusion here, is that you need to remember off the top of your head eventually, maybe you're not there yet, but you got to remember that cosine of 2x is equal to, cosine of 2x is equal to 2 cosine squared x minus 1. That's an identity. So now we have this is equal to this, which means you have 2 cosine squared on both sides. They cancel, so you're left with cosine of x is equal to negative 1. So x is equal to cosine inverse of negative 1. The cosine of what is negative 1? And that's pi plus 2 pi k. But it's on this interval, so we can take this away right here, and the answer is just pi. We only want the one answer that's in this interval. And yes, you also could consider the other cosine inverse, which is negative pi, but negative pi plus 2 pi k is just going to get you back to pi. They overlap. So the answer is still just pi. So if we're going to prove this identity in question number 2, remember for proving an identity, you have to start on one side and go to the other. And I know I've said in the past that you're supposed to take like the bigger looking thing and try to turn it into the smaller one, but in this case, you're going to go from the left to the right. You're going to start with sine of 3x. So we're going to start here and not touch the other side. What we're going to do here is we're actually going to turn it into 3x is 2x plus x, so that's the sum of two angles. And we know by the definition of the sum of two angles with sine that this is going to equal this right here. And then we're almost there. What can we do next? Well, there is one thing you might recognize right here. Sine of 2x from a couple classes ago. You know that that is actually equal to 2 sine of x cosine x. So I'll just highlight this. This is the same as this. The rest will stay the same. And this does seem a bit random. Sine of x, like this. So what can you do now? Well, what you can do now is that there is a sign in both of these. You have a sign here, and you have a, sorry, I'll do them right. You have a sign here, and you have a sign here. And so you can factor that out, and you get. So now what we're going to do is simplify just a little bit on the inside. So you still have this sine of x on the outside, which is what we want. I mean, that's kind of nice that we have it up there. So we're getting there. And then this is 2 cosine squared x. That's this one right there. And now we still have this cosine of 2x. Well, from our identities, from the multiple angle identities, we know that cosine of 2x right here, we know that cosine of 2x can be written as cosine squared of x minus sine squared of x. So then we still have this on the inside right here. So the same thing still holds. And now we can group some of these together. So now we have 2 of them and 3 of them. So we're getting there. We have sine of x and 3 cosine squared of x minus sine squared of x. If you want to know a hint of where to go, we notice that there's no sine in here. So what are we going to do? Well, we know that cosine squared plus sine squared is equal to 1. So sine squared is equal to 1 minus cosine squared. So we're just going to take this right here, 1 minus cosine, and put it in there, which leads us to this. And you have to be very careful. The negative is still on the outside. So when we distribute, we still have the sine x on the outside and the 3 cosine squared x, but then this becomes minus 1 plus cosine squared x. And now we have our 4th cosine squared. So when we put this all together, we end up with sine of x times 4 of them now, minus 1. And that's exactly what we wanted to prove right there. The key things on this one, we're realizing that you could take, sine 2x and do that. And then what do you do after you get there? You then have to take your next one, which is cosine of 2x right here. And we know that that turns into this. And then we also have our identity right here, the Babylonian. This takes practice. So let's play around with inverse trig a little bit. Cosine inverse of 1/2 is the cosine of what is 1/2. The cosine of pi over 3 is 1/2. Now the inverse was already there, so we're leaving it just one answer. And then the sine of pi over 3, you need to know that that equals root 3 over 2. That is something in the unit circle, and it's in the first quadrant, so you really got to know it. For this one, you first have to look at the tangent of 5 pi over 4, and that's all the way at 135 degrees. So you can think of it in terms of degrees if you really want to, but that you have to know. You do the inside first. The tangent of 5 pi 4 is just going to be it's going to be 1 because it's going to be in the third quadrant. If you want to know that, you have your circle right there. Sorry, it's not 135 degrees. It's going to be 180 plus 45, so it's 225 degrees. Excuse me, right there. So 225 degrees is right there. So what do you have? You have negative value and a negative value, and that's negative root 2 over 2 and negative root 2 over 2. So it's sine over cosine. They're the same. So then you have the sine of what is 1. The sine of what is 1, and that is pi over 2. And again, it's only one answer in this case because we're limiting ourselves on the domain. We're limiting ourselves on the domain of sine inverse. So again, you have to do the inside here. So 7 pi over 3, you can start to subtract 2 pi from that. That's 6 pi over 3. So that's the same as taking the cosine of pi over 3. So the cosine of pi over 3, you should know, is going to be, it's in the first quadrant too, it's going to be 1/2. Now it's asking what is the cosine of a half? What is the cosine of a half? Sorry, what angle has a cosine that equals a half? The cosine of what is a half? And that is indeed pi over 3. So now we get to find algebraic expressions that are equivalent to the given expression. And we're going to start at the inside here, and we're going to do the thing we've done before, which is build a triangle where this is the case. That's the theta, and this is the theta. Tangent, as you might remember, TOA is opposite over adjacent. So 2x, the tangent of what angle is 2x. So that means that 2x can be written as 2x over 1. The opposite side is right here. So that's the opposite side. And then the adjacent side is right there. So what that means is the opposite side is going to be 2x, and here is going to be 1. So then how do you find the hypotenuse here? How do you find this? You know that 1 squared plus 2x squared will equal, we'll call this h squared. So what do you end up with? You end up with h is equal to the square root of 1 plus 4x squared. Square root of 1 plus 4x squared. So then what's the secant now? What's the secant of this angle? What's the secant of this angle on the inside of this triangle that we made? Remember that secant of theta is equal to 1 over cosine of theta. Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So in this case, that's just going to be the square root of 1 plus 4x squared over 1. So our final answer here is just going to be 1 plus 4x squared. As a final note, it'll benefit you to spend some time taking a look at this question number 2 again. It contains a whole lot that you need to get comfortable with, and it just takes practice.